right. So looking at that waves puzzle, we're going to go through this together. Oh. All right. So we're starting our new unit today, and it's on waves. So it says waves or transferring energy through a medium. And so waves are the transfer of energy through a medium. So mediums are things like air or water. So they're just different places where you're passing through something. So right now, you're probably all in the medium of air since we are all breathing. If you like go underwater, or if you put something through any other liquid or some solid, anything can be a medium. So like the table that you're next to or your cup of water, all that stuff has different mediums or locations. And so these particles, particles are going to also behave like waves, and everything has wave functions, even you, but only the smallest particles exhibit significant wave behavior because it depends on the size and the mass. So right here, we're just looking at some diagrams of transverse sinusoidal waves. So lots of wonderful words right there. So if we look, we're just going to look at this section. And so we see there's two words on this section. We have nodes and we have antinodes. What do we think those mean? What do we think a node is? Just based off this picture, or an antinode? Anybody have any ideas? Take a guess. And I'm going to say that this right here is going to be like my x-axis.
The nodes are positive.
Okay. Nodes are positive, which means what about our antinodes?
Negative.
Negative. All right. I like that idea. It's going to be a little bit different though. So we're close. So the antinodes can actually be in two places. Antinodes are also going to be up here. So our antinodes are down here, right here at the top and at the bottom. And then our nodes are going to be over here. So our nodes are going to be at these points right here. So does that change our opinion about what antinodes and nodes are?
Nodes are the zeros.
Nodes are the zeros. Perfect. Nodes are going to be the point where we're crossing the x-axis or that we have a zero. And then antinodes are then going to be what? All right, let's write down the definition of a node first, since we have it. The zeros, or the points where the wave passes the x-axis. All right, so then what do we think the antinodes are? If we know the nodes are the zeros, the points where that x passes the our wave passes the x-axis, what are the antinodes?
Is it like the minimum and maximum?
Exactly, they're the maximums and minimums, or the minimums and maximums. Or the farthest points from the x-axis. So they're those farthest points from our x-axis, our maximum points and our minimum points. Do any questions on nodes and antinodes? All right, then let's get to wavelength and amplitude based on this wave right here. What do we think wavelength is? What do we think it means to have a wavelength? We're talking about wavelength. The distance, awesome. So it's going to be the distance. What specific distance do we think we care about? Like the wavelength is right here to here. What distance is that for us? Distance between the nodes of the antinodes, perfect. So let's write. Let's be more specific, between two nodes or two antinodes. And I'm going to do something that English frowns upon. When you're in English class, you're coming up with definitions. I'm just going to write down that it's the length of one wave. So I know you're not supposed to use the words in a definition, but it's just going to be our length of one wave is our wavelength. And so just like I was told earlier, it's the length between two nodes or between two antinodes. So how many waves do we have up here in this wave? How many waves do we have? If we know the wavelength is one wave, how many waves do we have? Two, perfect. Because if we're starting here, our first wave goes up, comes back down. This is going to be our first wave. And then our second wave is going to start here and go up and come back down, come back to here, and create our second wave. So we have two waves on this wave right here. All right, the last definition is amplitude. What do we think the amplitude is? Based on that picture.
The height between the x-axis and the highest and lowest points of the antinodes.
Exactly. Height between x-axis and the maximums and minimums. Perfect. We are crushing these definitions. You guys are doing fantastic. Do we have any questions on these 4 parts of a wave? All right. So then the next question, question number 1, talks about thinking back to math class. What do you think the word sinusoidal means? And I might be mispronouncing it. That's just how I learned how to say it. So if you think you're saying it better, that's perfect. But sinusoidal, when we're looking at it, think specifically about this wave right here. Don't think about this one with the nodes and antinodes. Think specifically about this one. What do you think sinusoidal means in math class? Think about math terms It might not be something specifically you've seen, but think about math terms and maybe some graphs that you've seen in math class. Hopefully you've seen graphs in math class. Who has a guess, an idea of what this sinusoidal would mean in math class? Anybody? Think about like the root of that word. Sine, awesome. So the root of that word is sine. And this kind of looks like what? If I put another line here and call that the y-axis. We could
It
call
looks
this
like sine when you graph it.
perfect. It is a sine graph. It's sine when we graph it. Awesome. So sinusoidal really just makes a sine graph. So our waves are going to look like those trig function graphs, either sine graphs or cosine graphs, depending on if we start here or if we start up here. It'll look like sine and cosine graphs. All right. Number 2 says that symbol for a wavelength is a lowercase Greek letter lambda. So we need to know the symbol for lambda. Does anybody see what that symbol is? Anybody see it? It is there.
Is it by the words wavelength in the graph?
Exactly. It's that by the words wavelength in the graph. It is that upside down Y looking thing. Lambda looks like an upside down Y almost. So if you ever see that, that's telling us we are looking at the wavelength. All right. On number 3, it says since the negative wave and antinodes are labeled above, write A on all the positive antinodes. And that's talking about up here, writing A, up at these wonderful spots we talked about. Up here. Down here, I want you to label everything, all 4 of the parts. So label the nodes, label the antinodes, label the wavelength, and label the amplitude. I'll give you guys about 2 minutes to go ahead and do that, and then we're going to continue. So you guys, 2 minutes, label those 4 parts, and then we'll continue. All right. So hopefully you guys got that down. If you have questions about that labeling, let me know. Otherwise, we're going to frequencies. So we're talking about frequencies in a wave or on a wave. So for this one, we're looking at these two different waves. We have the top wave and the bottom wave. They have different frequencies and periods. So first thing I want to know is for every wavelength in the bottom wave, how many wavelengths pass on the top wave? So every time we have one wave at the bottom, how many do we have up at the top? Three, perfect. So let's see, we have one for this right here. We have 1, 2, 3 up here. So we have those 3 waves. Wonderful. And so we're looking at those frequencies. So the top parts right here. How do our frequencies compare to our wavelengths?
One frequency is higher to the other. So like the wavelengths are closer to each other.
Awesome. The wavelengths are closer to each other, so the frequency is higher. The top one has 3 times more frequency than the bottom wave. So all right. And number 7, how do our periods compare? So the period of the wave, how does that compare?
The bottom is like 3 times larger than the top.
Awesome. The bottom has 3 times the period of the top. Wonderful. Awesome. All right. So we know that the frequency is larger in the top wave and the period is larger in the bottom wave. We know based right here that frequency is the letter F and it has the units of hertz, which are really just 1/seconds. So the inverse seconds or 1 divided by seconds for our units. And we know that the period is going to be the amount of time. So it's capital T for period, and it's going to be time in seconds. So what do we think the definition of the frequency is going to be based on what we know about these 2 waves up at the top and what we know about the units? What do we think that definition is going to be? Take a guess. Doesn't have to be right.
amount of waves per second.
Awesome. So the frequency is just how many waves we have in a second, because it's per second over here, or 1/seconds for our units. So it's just the number of waves we see or that pass in 1 second. So it's the number of waves per second. Right. And then what do we think the period's going to be? Remembering that we can see 5 waves in a second for the bottom wave, and we see 15 waves per second in the top wave. What do we think that period is? The time it takes to make the wave, or to make one wave perfect. Right. Nice. All right. So we're going to get through question number 8 together, and then I'm going to let you guys go and work on the rest of it for the next 15 minutes. So the question 8 says, what's the relationship between frequency and period? So are they directly related, or are they inversely related? What do we think? They're going to be inversely related. That is correct. And they're inversely related, which means what if we're trying to write down words? What does it mean when it's inversely related? All right, I'll start us off. As the frequency gets larger, the period gets what? Is it also going to get larger, or is it going to get smaller? What does it mean if it's inversely related? As the frequency gets larger, what happens to my period? It gets smaller. Perfect. Awesome. All right. So down below, you have 2 things you got to do for number 9. You have to draw 2 different waves, one in red and one in blue. The one in red is going to be when you're doubling the frequency. The one in blue is when you're doubling the period. Make sure you're getting through at least question 9, and then I would say try and look at the next page, on page 10. Guys, we're gonna do more of this tomorrow, so it's not required to get through page 3 and 4. By the end of the day, we'll go through some of this tomorrow. At least get through question number 9. If you have questions, let me know. Otherwise, you guys are good to go work on the rest of this on your own. And how